them and tell them where you are? We just literally have been visiting around different places.
Okay, yes, I know you guys have had a busy day today. Let me play this, and then there'll be a little action shot here. Yeah, okay. So my name is Cody. So I'm on the Marcus G. Langseth, which is a research boat run by Lamont-Doherty. I know you guys have been busy today. You went to the core lab already and the polar lab, and I think next is the plankton. Is that right?
Yep, that's it.
Yeah. Yeah, so seen a few different things that Lamont does with regards to science and sort of exploring the world. So we're on another one here. So right now, let me share my screen here. So right now, you guys are in Lamont-Doherty, the campus there in New York. So let me show you where the boat's at. I'll zoom out. So of course, we all recognize Long Island, the Great Lakes. So right now, we're working down in the South Pacific, down by Mexico. So Mexico's here, of course. So this green box is where the vessel is at right now. So let me zoom in here. So you can see sort of our vessel track back and forth. So we're making big circles in the ocean as we tow the equipment behind the vessel. So we can do a few things on board the boat. We do geophysical research. So we look at, I'm sure maybe in your science class, you study plate tectonics, volcanoes, earthquakes. So we're looking at sort of how the plates work together. So the different fault zones, you have the convergent and divergent zones. So we do geophysical type research. We also map the bottom of the seafloor using sonar. We do gravity and magnetics. And the other side of the coin is the oceanographic work we do. So that would be taking water samples all the way down towards the bottom of the ocean. So 4,000 meters down. That's taking a temperature profile. That's looking at different currents. So you're going to be talking to the plankton lab next. So we can actually take samples on board the boat and they can study plankton on board here. So we've lowered big microscopes down into the water so they can actually look at the plankton in the water without bringing the samples up on board the boat. So quite a few things that we do sort of as we go offshore. The boat yeah, go ahead.
For 2 seconds. I was just going to say, so you showed us that the tracks of the ship, and I just wanted to bring back where we just were in the polar lab, and we looked at the mapping tracks. We call this kind of mowing the lawn. So you go the stack of the ocean. We saw the tracks that they did to identify the Gamberts of mountains. So a similar thing, and again, geophysics again, where we're using physics to be able to collect this Earth data. So yeah, there's a perfect example. Thank you for adding in those different runs. And how close together are your tracks?
So they're 150 meters apart.
Okay.
Yep.
So this is how we understand like the full ocean, right? We do it a little section at a time, which is really cool. Thank you. Sorry for interrupting.
No, that's okay. And if anybody has any questions, it's more of a conversation as opposed to a lecture. So if you do have a question, raise your hand as I go and we'll definitely get to it. And then at the end, we'll have time for questions, of course, as well. Yeah. So just like the mowing the lawn, we want to be able to get the coverage over the area that we're trying to study. So we don't want to leave any gaps. So when we build that data, we have one continuous coverage. Another thing that we can do, I talked about the sonars before. So we can make a map of the bottom of the ocean. So here's a good example of a 3D. Here's a good example of a 3D picture of a couple of volcanoes. So this data was collected on board in December. Let me play it again because it was pretty quick there.
It looks like the moon.
Oh yeah. So quite a bit of the world's oceans are actually unmapped. So the oceans make up 70-ish% of the Earth, and of that, only 27% has been mapped with high-resolution multi-beam or sonar type data. So there's a lot of the oceans that are unexplored. And maybe you've heard in the past, it's often mentioned that we know more about the surface of Mars than we do our own oceans. So if you look at Google Earth, let me show you an example. So if you look at Google Earth, so if you look at home and you say, well, now wait a minute, Cody, I look at Google Earth and I see the bottom of the ocean. I see the mountains and trenches and valleys, etc. But if we zoom in, so does everybody see right where my cursor's at? Do you see where it's a fuzzy? It's not so defined. For example, is this area here? Does everybody see that?
Yeah.
Yeah. So this fuzzy area here, that actually hasn't been mapped. And what they do is they use satellite data to make an estimate of what the bottom of the ocean looks like, and it's called satellite altimetry. And they use gravity data or slight changes in the surface of the ocean to predict what's on the bottom of the ocean. I mean, in general, this is an amazing piece of technology that a satellite from space can tell us what the bottom of the ocean looks like. But of course, it's not as good as actually high-resolution sonar data to map the bottom. Yeah.
And this is just exactly like what we were looking at when we were looking at the bed map of underneath the Antarctic ice sheet, where we saw areas that had been mapped in high resolution and areas that were just kind of interpolated using broader data sets. So perfect.
Yeah, exactly right. Yeah. So on board the boat, I don't know if you can see behind me there, so you can see some people working. So this is the main lab that we're in now. So there's 40 different computer monitors up as all the data is coming through live. You can see a couple. So over here, there's some scientists. Let's look. So there are some scientists over there. Behind me here, this person right here. So they monitor for wildlife. So they're a protected species observer, and they monitor for whales and dolphins, because when we're doing our scientific work, obviously we don't want to harm any animals that are around us. So we have dedicated biologists on board, and they watch the ocean two ways. They watch it visually, and they also have a cable that's behind the boat. It's called a PAM cable, passive acoustic monitoring, and they can listen for the vocalization of whales and dolphins. And once the whales and dolphins come within a certain radius of the vessel, when we're working, we stop what we're doing to make sure that we don't harm anything. So this is what this PSO is doing behind me. And we have other different people on board. So there's 45 people on board right now, and we leave port or we leave shore, and we're gone for over 42 days at a time before we then come back into port again. So we all live and work on board the boat together, and the boat runs 24 hours a day. So there's someone always working. There's someone always here watching those monitors all the time. And the shifts are a little bit different per person. Shift is the time that you're going to work. So most people down here work a 12-hour shift. So they start at noon and finish at midnight. And of course, we have everything that you would need to have on board. We have a small gym. Let me show you a picture here.
These are the important things, right?
Yeah. So here's the gym we have on board. So it's not glamorous, but it gets the job done. So this would be an example of the bedroom. We call them cabins on board. So this is where the scientists are going to live and stay. There's 3 beds in here, so 3 people are going to stay here. Let me show you a drone footage of the boat, so you sort of have an idea of what it looks like. Here we go.
Sort of like your dorm room, since you go to college.
Yeah.
So here we're coming up on the back of the boat, and offshore we have these different names we use. So this is called the stern. So we're coming up on the stern. Now we're going to come on the right-hand side, or what we call the starboard side of the boat. And you can see on the back, on the stern, those are all our working decks. That's where we deploy all the scientific equipment into the water. And here on the starboard side, so you see that big gray square? That's called the A-frame. And that's where we deploy other pieces of equipment, which I'll show you in a video in a little bit here. We're coming up on the front of the boat now. That's called the bow. And you can see at the top of the boat, there's that big, thick blue line. And right below that, you can see the windows. That's the bridge. That's where the captain works with the bridge officers. So there's always someone up there driving the boat. We're coming now on the port side of the vessel. So you can see right in the center, there's sort of a tower right in the center. That's where the PSOs, they go up on the tower with big binoculars, and they're looking for whales and dolphins in the water. So let me show you a couple more pictures here. So just like sort of like at home. What's that?
What's the spear on the back of the boat? The back of the ship?
The spear or sphere?
The spear, the circular radar.
Yeah, that's where we get our internet. So we have inside that, there's a big dome. So it's a big dome, and it's a antenna that moves back and forth with the movement of the boat. So that's where we get our internet. So we have two different types. We have what's called VSAT, that's the name of it, and we also have Star Shield. So just like the Elon Musk satellites on board here, it's called Star Shield. Yeah.
Thank you.
So let's look at a couple more pictures here. So we have a small hospital on board. This is what this looks like. So a small hospital. Here's the second picture of it. So this is the bridge. This is where the captain drives up there. One thing that you don't see is a wheel. So the boats don't have the wheels anymore. Everything is just like a PlayStation. It's a small little joystick that they drive back and forth. So it would be quite familiar to your game system. We have a little movie room as well. Let's see that. So we have movie. We have games in there. We have guitars and all sorts of different things. Yeah.
How many people can normally would be on a cruise? You said there were 40 some right now. Is that
yes.
What capacity and what is your norm?
There's 40 to 45 when we're on a scientific mission. When we're just transiting from one port to another, it's about 25 people. But when we're actually doing a scientific expedition, 45 is the limit. Yeah.
Thank you.
Does anybody have any questions on the boat and living before we look at some more videos? Nothing?
I don't see anybody jumping in. Sorry, I have a tendency to just ask questions, so
that's okay.
Maybe I asked all the questions.
If you guys were on the boat, what would you want to have? What about the person up front here in the red shirts? That's what happens when you sit up front.
I think it might be you, right? You're not up front.
I don't know.
Oh, Mara. Oh, you got a red
Good
shirt.
food, I guess.
Good food. That's a good question. Yeah. So here's our cafeteria. We call it a mess room offshore. So we have the cafeteria, and this is what and the kitchen is called the galley. This is where they cook our food. So it's a lot smaller than your school cafeteria, I'm sure. But we have, like last night, we had pizza and chicken wings for dinner.
Oh, yum.
Yeah, that's a good question. Okay, so next let's look at some of the stuff that we deploy over the side. So sometimes the days are calm. Let me try to share this.
I didn't know he was on the ship.
What's that?
Nothing.
Let me try to share this.
That's a good question.
So this is the view outside right now. So this is one of our ship's TV. So you see, it's nice and calm. This is on the starboard side of the boat. So it's nice and calm. But some days it's not like that. Some days it's more like this, which is a little bit rougher.
All hands, hoist the colors high. Heave ho, thieves and beggars, never shall we die.
So you don't have everything tied down?
So sometimes yes and sometimes no. When we're working and deploying stuff, so those pallets you saw sliding back and forth, we were deploying equipment off those quite quickly, and we had them stacked up on the side, and we caught a couple big waves, and they were sliding back and forth.
Gotcha.
So in general, yes, but sometimes we get caught unaware. So this is what we were deploying. We were deploying what's called OBS, which is ocean bottom seismometer. Here's a picture of one that I'll show us the video here. So there's these units, they're about as big as sort of a coffee table, and they float down to the bottom of the ocean, and they sit on the bottom, and they listen passively for any type of earthquakes that are forming. So that's a picture. Let me show you the video. One second. Here we go. Oh, it's not it. Yeah. Yep. Just one second here. So this is a working boat. So sometimes I have to take a break and answer a question. Here we go.
I've been the one. You have been the one for me. Goodbye, my lover. Goodbye, my friend. You have been the one. You have been the one for me.
So that was the video going over the side, and this is the video of it going in the water. Was there a question, Marjorie?
Cody,
Who knew it'd be so blue?
as always. So, do you deploy more than one of those in a series? Would you like deploy a set of them on the ocean bottom, or would you ever just deploy one?
So it's normally deployed in an array. So we'll deploy anywhere from 20 to 50 of them at a time, and in a type of an array that the scientists want to look at the data. So let me show you a job that we have coming up in July that we haven't done yet, and I have the files for that. But below us right now, we have there's 5 OBS on the bottom right now, and they were deployed there last year because there was some recent volcanic activity. So let me actually show you a video of what's below us because it's pretty neat. It looks like it's right off Discovery Channel. So this video was shot by the submarine Alvin, and this is what's below us right now. Let me remove the screen, share this one. So this is what's currently below us. Let me see if it plays.
Oh, that's cool.
Can you guys see it?
Yeah.
So that's what's below us right now, and there's black smokers. There's this black smoke that comes out of them. So this is quite a volcanic heavy area because this fault that we're on right now is a divergent zone. So the two plates are spreading apart right here, and it's causing the heat and the magma to come up and form new oceanic crust. And when it does that, you have whole ecosystems that are made around these areas. Yeah, so there's 5 OBS on the bottom right now, sort of around where we're working. So let me remove that.
Cody,
And
do
let
you
me
ever
show you.
work when you deploy an OBS that you'll hit something, create some kind of damage, or leave a scar or something on the bottom of the ocean, or is that not a consideration?
Not especially. I mean, it's the footprint is so small. You know, we're talking 2 feet by 2 feet, and it's such a tiny area. And then when it lands down, it just sort of settles down. So it drops very slow. So the depth of the ocean that we're working right now, it could take 2 hours for the OBS on surface to fall all the way to the water column down to the bottom. So it's quite a slow descent. And when it sits on the bottom, we have videos of the OBS landing on the bottom, and it just sort of just settles down on the bottom itself. So it's not a real concern.
Okay.
Let me show you this proposal here to answer your question about the OBSs. So this job is off of Georgia, and we're going to be, for this expedition, we're going to be there in July. So let me show you what that looks like. So can everybody see the map now? And you see the red dots?
Yeah.
Yep. So each red dot is an OBS location. So for this particular expedition, they want them sort of in a line with 3 crosses. And then when we're going to deploy the equipment off the back of the Langseth, we need to make the noise. So it's similar to how a bat flies when we're looking at the data. So you know how a bat, it makes an echo or makes a noise. The noise goes out, echoes off a tree, a barn, it comes back, and the bat can listen to it, and then it can make an image of its surrounding. Does everybody know how that works? Yeah? Yes? So
Naughty.
so we do something similar with sound offshore. So behind the boat, behind the Marcus G. Langseth, we tow some big air. So it's compressed air, and it makes a big sound into the water when we let it when we release it. And that sound goes down and it reflects off the different rock layers, and then the reflection comes back and we measure it. And when we measure it, that's just like the bat listening to it. And then with the computers on board, we can make an image of the rocks below the ocean. And these OBSs are similar. Instead of listening to it behind the boat, we put them on the bottom of the ocean, and then we make the noise, and the OBS records that noise as the reflection and refraction comes back to them on the bottom of the ocean. And then later we go back and we get those back off the bottom.
How many captains are on board?
So there's one captain on board. He's so the captain is the overall in charge of the vessel. He has overall authority of what goes on with the safety and of the crew in the vessel. And then there's different departments as well. So there's many different sort of ways to be able to work on a research boat. So I actually have a slide for that. So I already talked about the biologist. That's one sort of path that a person can work on board a research boat. But you have technicians, you have IT people who know coding, who are good with computers. You have the people who cook the food, the steward, the cook. You have the engineers, just like on Star Trek. You have the captain and chief engineer. We have that here as well. So you also have, of course, the scientist. So the scientists are anybody from a PhD, a professor, all the way down to an undergraduate student who's maybe a freshman or sophomore in college who comes offshore and as part of the science team. So there's many different ways to be able to sort of come and work on board a research boat like this.
How do the high school students get involved, since I saw some smiles?
So there's a couple different ways. There's a program called STEM Seas. That's a good program. And there's different sort of internships that are out there. What I would suggest to do is go on to the different sites, whether it's LinkedIn or Twitter or Facebook, and follow the organizations or companies that you're interested in. So if you're interested in, for example, the ocean world, UNOLS is a good example. So UNOLS is the organization that sort of governs the research vessels that go offshore. So there's many different places to follow, and they often provide internships and different opportunities for people to get involved.
Thank you.
Yeah. Any more questions?
If there's one captain, does he drive like the whole time?
So on the bridge, they have a hierarchy of people. So the captain is the number one, and below that there's the chief mate, the second mate, and third mate, and they split that up into 4-hour increments. So the chief mate, for example, will have the noon to 4 p.m. watch, and then he'll come back on at midnight and work until 4 a.m. So they split the day up into 4-hour watches, is what they're called. The captain actually doesn't stand a watch on the bridge, but if something important happens, the captain, of course, comes up and then they're there to handle any important decisions. But the day-to-day running of the vessel, or at least driving of the vessel, are from the 3 mates, is what they're called: chief mate, second mate, third mate.
Got it. Thank you.
Yeah, and the engineers are similar. So there's the chief engineer, and then the first, second, and third engineer.
Okay, so then what is the captain doing if he's not driving?
Probably
the boat,
sleeping,
Or they
right?
are not driving. They're not sleeping.
Really?
Yeah.
Sleeping.
So a lot of it is administrative. It's so the captain is in charge of, let's say, like this location. So he's making sure that all the routine maintenance is getting done. So we have a maintenance program on board to make sure that the antenna is being checked or the engine's being checked, and so the captain is making sure that's being done. He's in charge of the safety of the vessel, so he's doing walkarounds to ensure that the different rules and policies are being followed. Any type of ordering or requisition, any type of personnel management. The captain is also in charge of the hospital. So if anybody has any issues related to their health, they would go see the captain. The captain would then go to the hospital. We have a capability that's called telemedicine. We can talk right to a doctor at George Washington if there's any type of issues like that. So the captain is the overall charge, but just like any type of organization, just because the captain is in charge doesn't mean they're doing every job, right? So they delegate those jobs out. So a well-running organization, the workload should be spread out based on the competency of the person who's doing the work.
So then that means you don't have a medical professional on board.
That's right. Yep. Yeah. Now the captain has gone through quite a bit of training to sort of support that role, but no, they're not sort of an EMT or a paramedic or something like that.
That's interesting to me, actually. I would have expected it. I mean, I wasn't expecting a doctor or, anything of that high level, but I was thinking that maybe they would have, some kind of medical person there for the period of time you're away.
Yeah. Yeah. I mean, with his training and then with the internet capabilities, so with a telemedicine machine, so they can hook the instrumentation up to a person and then they call into the doctor, and the doctor real time can log into that machine and see the health vitals or the statistics of that person, and they can make decisions real time.
So can I ask a question that comes up a lot with Antarctica then, in
Yeah.
terms of screening before you go? So, you have to pass a pretty high medical clearance to go there because there aren't doctors. Is it similar for people going onto the ship?
So we don't have anything that's required to come on board. We recommend that before a person comes offshore, they go to the doctor and dentist for a checkup. There's nothing worse than having something wrong with your teeth offshore. So it's something that we recommend that before you come something like this, if you're going to be gone for 40, 50 days, you want to get checked up to make sure you're healthy before you do come on board the boat. Yeah. And make sure if you have any medication, of course, you're going to bring plenty of medication for your trip.
Thank you.
Yeah. Any other questions? I know time is fairly short now, but
Is that a question I see brewing? We're thinking over here. We're
Okay.
hoping to formulate a question.
let me show you some. While you think, I'll show you a couple pictures. So this is a small video of some of the crew that were on board, some of the scientists. So in this particular trip, this was more of an oceanographic trip. So it was all the lab spaces were set up like chemistry labs. So we were deploying instruments into the water to take water samples. We were deploying big nets into the water, almost like big butterfly nets, to take plankton samples. So there's those big nets there. Yeah, so this was more of an oceanographic type cruise. Here's some footage. Oh, here's we were coming into Mexico in December. Here's a good picture of a good video of some whales. So these are humpback whales coming into Mexico in December. So this was quite nice. This was right in port, actually. There they are. Yep. And then I'll show you another quick video here. So we get to go to some fun places when we're on board. We travel all over the world. We were in the Galapagos last summer. So here's some footage of the Galapagos here. So this was some of the crew were scuba diving.
Oh, this is a great way.
It looks more like a black tip.
Isn't that cool?
That's you, turtle.
So that sea turtle was just a couple feet below me. It was almost touchable.
And it's so relaxed how slowly they move. It's like
Oh, yeah.
meditative.
Yeah.
Very
That-
cool.
That one with the number 1, he's the fastest.
He's the
I doubt it.
fastest.
There's a couple locals there. And those are some lava tubes there, actually, that we were able to walk through. So, yeah.
Do we do have a
videos.
question?
Huh? Yeah, go ahead.
How are you guys funded? Are you guys like grant funded or by the university?
Yeah, so the professors or researchers put in a proposal to the National Science Foundation. So they say that we want to go to this area, and this is what we want to study. These are our objectives, A, B, and C. And along with that, we're going to do certain types of outreach, or we're going to bring young scientists on board as part of the work. So that proposal goes into the National Science Foundation. It then gets peer reviewed to make sure that the goals of the scientific study are going to value sort of a knowledge of our understanding of the world. And then, so if it gets funded from the National Science Foundation. And then they fund basically vessel time. So they say you're approved for 30 days on board the Marcus G. Langstaff in July, August or something like that. So that's more or less how it's funded.
So it's all kind of centralized. Yeah.
Mm-hmm. Mm-hmm. Yep.
So they receive that money from the government or like other aids to basically allow you to be on the boat for that time.
That's right.
Okay.
Yep. Yep. So here's another picture. So I mentioned the compressed air, the air source. So here's us deploying that air source out the back of the boat. So there's 4 of them. So it's quite a lot of gear to put in the water here. So here's one. So it just slides out the back there and then it floats behind us.
Cool.
Any more questions? Some good questions so far.
We have a question.
What's your favorite thing to do when you have like off time or you're not working?
So I normally like to read, either that or just like, walk outside on the open decks. So we have a small library on board. I don't think I showed it. Here's this. So we have a little small library with some different books. It's not big, but it's what we have. But most people bring Kindles and stuff like that now anyways. So, but that's what I like to do. Yeah, get some fresh air. Yep.
I would say that you spend a lot of time also doing, so this is a program that Cody started, this whole deck to desk, or is it desk to deck? I can't remember, but it is, which one is it?
Desk to deck.
Desk to deck. Okay. This is a program he started and he's been doing outreach with different schools. He works with, scout groups and a variety of different groups just to help people understand what it's like to actually work in this field and the experience that you can have, because people have no idea. I mean, I expect you all probably had no vision of what it would be like to be out on an ocean vessel and what kind of work they're doing and what would be some of the pathways to get there. So Cody spends a lot of time on it and he's really good at it. So we really appreciate having you as like an ambassador for
Thank you. Yeah.
the Marcus Langstaff and all the time you put into it.
Yeah, I talk with young fives. You can imagine how that conversation goes. I have a lot more cartoon pictures, less words, all the way up to kids in college. Yeah. So I'm going to go, we're going to sail. So after this particular expedition, we're going to be back in San Diego, and then we're going to sail to Hawaii and then the Marshall Islands, which are on the opposite side of the international date line. And when we get there, I hope to stop and talk to some schools when we get there in person, and sort of tell them more a little bit about research and the different opportunities that exist sort of outside the island community. So yeah, should be fun.
Which is really great. And then the summer, I'm gonna zoom in with our summer interns and share with them because they're all focused on marine science, polar science. So kind of the same combination. So cool.
Cody lives like full time on the boat, basically.
Cody, you want to answer that?
You live like full time.
So the techs are here about 180 to 200 days a year. So 6 months a year, and so it's not 6 months all in one go. It's the rotation varies depending on the expedition. So it could be 4 weeks on the boat and 4 weeks home, or it could be 4 weeks here, 6 weeks home. It just depends on what the rotation looks like. But it's more or less 6 months a year on board here. So yeah.
Which is a big commitment. Yeah, it's not for everybody. Sure.
No, it's not for everyone. Yeah. But when you're not here, you have 6 months off, so it's not too bad either.
Oh, there you go.
Yeah.
Wi-Fi.
Yeah.
Oh, like the satellite.
Are there any other questions? Because that's a cool OBS array. All up on the deck, and look at that water come. So I assume when you're deploying equipment that you need to have a fairly calm sea. You're not going to run streamers in a lot of wave activity, correct?
That's right. Yeah. So depending on what we deploy, part of the risk assessment that we look at before we start the operations is what the weather is right now and what it's going to be in 6, 12, 24 hours from now, to ensure that once we start, we're able to continue with still weather that's both safe for people, of course, but also safe for the equipment. We don't want to damage the equipment either. So that goes into the pre-deployment risk assessment that we do on board. So obviously safety is a big thing. So it's something we think about often. We're looking at the different weather reports. We have a lot of different training in sort of safety and risk mitigation to understand what that looks like offshore, because we are so far away from any help. Yep.
Yeah, that would definitely be something to pay attention to.
Yeah.
We
Here's
probably
a
need
couple.
to
Oh yeah,
move
sorry.
on.
Go ahead.
No, I was just gonna say we probably need to wrap up, but I'll let you finish and then we'll thank you.
Oh, I was just going to show a couple. So these are some interns here. They were on board last year, so they were freshmen in college. So it's not too long, or not too far from where you guys are at now. I think. What grade are you in? Sophomore,
11.
juniors?
11 and is there anybody in 12th that's here? All those seniors booked out on the trip and didn't come. I tell
Yeah,
ya,
like,
the younger are better.
Well, they missed out.
They did. You guys can tell them all what they missed. Thank you so much. We really appreciate it. We're going to head off to Plankton, but it was great. I'm looking forward to chatting with you. I'll follow up with you later, but
Okay, great. Thank you very much. Bye-bye. Bye-bye.